In this video, we're going to talk about fractional exponents and how they relate to radicals. So let's first of all make sure we agree on what the definition of an exponent is. What does it mean to raise x some number to the n power? For example, if I had 2 to the third power, what does that mean when we just put a number, make it smaller, and move it up a little bit? And hopefully we all agree what that means is I'm going to multiply 2 times 2 times 2 three times, multiply the number by itself three times. In this case, that would give me 8. So x to some power n means I'm going to multiply x times itself n times. N times. Okay. And hopefully you've reviewed some of the other properties of exponents, like negative exponents, and what happens when you multiply uh, two numbers with the same base with different exponents. What do you do with them? What we want to focus on right now is how do we make sense of an expression, something like 9 to the 1/2 power? Because even though we have a definition for what an exponent means, you can't multiply 9 by itself a half of a time. That just doesn't make sense. So how can we make some sense of what it means to raise 9 to the 1/2 power and what it should equal? And so to come up with an answer for that, we're going to use the multiplication property of exponents. And what that is that's the situation when you're, say, for example, if you have x squared times x to the third, what do we do with the exponents when we're multiplying? Again, they have to have the same base. Well, you, you may or may not know what to do with that, but it's an easy to explain that if we use our definition of an exponent. X squared means I multiply x times itself twice. X cubed means x times itself three times, and these are all going to get multiplied together. So how many x's are there multiplied together? There's 5. That would be x to the fifth. And so the multiplication property of exponents says when I multiply two numbers with the same base, I get to add the exponents, and that gives me the correct answer. Okay. So, and that's actually how we can make some sense of what 9 to the 1/2 should be. If I multiply 9 to the 1/2 by itself, by the multiplicative property of exponents, I should add those together, 1/2 plus 1/2, but that gives me 9 to the first, which is just 9. So then, what does this mean? That means whatever we think 9 to the 1/2 should be, if I multiply it by itself, I should end up with 9. So the only number that's going to work for is 3. 3 times 3 equals 9. So what that means is 9 to the 1/2 power is 3. Now you might be thinking already of what is that? What's another way to get to that answer? But let's try something else here. Let's say I wanted to know 125 to the 1/3 power, and I wasn't sure what that was. I could do a similar thing. I could multiply 125 to the 1/3 not just by itself one time, but if I multiply it by itself three times, we should be adding those exponents. 1/3 plus 1/3 plus 1/3 would once again give me 1. So whatever 125 to the 1/3 is, if we multiply it by itself three times, we should be getting to 125. The only number that would work for is 5. 5 times 5 times 5 would give me 125. So 125 to the 1/3 is the same thing as 5. We'll come back to that in a second. So then think about in your head, how would you figure out what 16 to the 1/4 is if you didn't really know what it meant? And hopefully you came up with, well, if we multiply it by itself 4 times, in the same spirit as we did the other two problems, that's going to give me, if I add those exponents, 1/4 plus 1/4 plus 1/4 plus 1/4 is 1. So this 16 to the 1/4 has to be a number that we multiply by itself 4 times to give me 16. That would be 2. 16 to the 1/4 equals 2. So now you're probably picking up on this. What does this really mean? 9 to the 1/2 is 3. A number times itself twice, that gives me 9. That's exactly what we mean by the square root of 9. 125 to the 1/3 turned out to be what number times itself 3 times gives me 125, which was 5. That's exactly what we mean when we say take the cube root of 125. And same thing with 16 to the 1/4. That is the same as the 4th root of 16. Okay, so that's the connection. If I have some number raised to the 1 over n power, that's the same thing as taking the nth root of that number. By the way, just a reminder with radicals, 4th root, cube root, when we do a square root, technically, I guess you could imagine a little 2 there. We don't usually put it because square roots we work with more frequently than other types of radicals. So square root really means there should be a 2 there, but we don't have to write it. Okay, now what if I wanted to simplify something like 27, not to the 1/3, but something 27 to the 2/3 power? This only tells us how to do x to the 1 over n. This is 27 to the 2 over a number. So the secret, how I can do this, is I could rewrite this in a couple of ways using our properties of exponents. I could either write this as 27 squared, then raise that to the 1/3, because recall when you have a power to a power, these exponents would get multiplied. I'll write that right here. If I have x to the m raised to the n, that's the same thing as x to the m times n. That's another property of exponents you should be familiar with. And so what this would mean, we know what the 1/3 means. That would involve taking the cube root of 27 squared, which is 27 squared is a big number. That's not going to be easy to figure out what that is. Fortunately, there's another way I could rewrite this. I could just flip these two numbers around. That would be the same as 27 to the 1/3 squared, right? Because when you multiply those, you're still going to get 2/3. So what does this mean? This means take the cube root of 27, that's inside the parentheses, and then square the answer. Much easier. Cube root of 27, a number times itself 3 times, that gives me 27, would be 3. And 3 squared, 3 times 3 would get me to 9. Let's try one more like this. If I wanted to figure out what 16 to the 3/4 is, I could do similar to how I did the last one. I could either do 16 cubed and then raise that to the 1/4, or I could do 16 to the 1/4 and then cube my answer. And hopefully you have an opinion about which one would be easier to do. This is a big number, right? 16 cubed, I don't know what that is, right? And then I'd have to raise that to the 1/4 or take the 4th root. So even though we can do it either way, almost always it's easier to do the root first, write it like this, because then it allows you to take the 4th root of a smaller number and then just cube the answer. We already did the 4th root of 16. We saw that when number times itself 4 times, that gives me 16 is 2. So 2 cubed is 8. So what's our takeaway here? This is maybe a more useful formula than the other one. If I have x to the m over n, the best way to do it would be to take the nth root of the number and then raise that to the nth power. We could do it the other way. I'm not even going to write that down because this is almost always going to be the easier way to do it. So take a second. Well, okay, we'll do this one together. So if I see 100 to the 3/2, now what I know what this means, the bottom number tells me the root. So this tells me I want to take the square root of 100. And the numerator of that fraction tells me to then raise that answer to that power. Square root of 100 is 10. 10 cubed, 10 times 10 times 10 would give me a nice 1,000. Okay, it's be a good time, pause the video and figure out what 8 to the 4/3 is. Hopefully you tried that and realized the best way to do this would be to take the cube root of 8 and then raise that to the 4th power. Cube root of 8 is a number times itself 3 times. That gives me 8, which is 2. And 2 to the 4th is 16. 2 times itself 4 times. One more. Don't forget, the rules with negative exponents still apply. If I wanted to do 32 to the negative 2/5, the first thing I would do is know that that's the same as 1 over 32 to the positive 2/5. And then it's just as we were doing. To figure out the denominator, I would take the 5th root of 32 and then square that answer. It's getting a little bit tough here, but a number times itself 5 times that equals 32. If you work it out, it ends up being 2. 2 times itself 5 times is 32. So it's 1 over 2 squared, which is 1/4. Okay, so one of the main points of this discussion here is to convince you that fractional exponents and radicals are one and the same. So if you ever get stuck in one form, just try changing it to the other. We've been working on problems that involve a fractional exponents. We've been changing them to radicals, but sometimes if it's confusing, when you have a radical problem and you're not sure how to do it, you could change it back to fractional exponents. For example, if I want to know what square root of 3 to the 6 is, I know that the square root of 3 could be written as 3 to the 1/2. And then I'm raising that to the 6th. And I also know when I have a power to a power, I'm going to multiply these together. And 1/2 times 6 is 3. And 3 to the 3rd is 27. Try doing number 2. Maybe pause the video for a second and see if you can figure out what that simplifies to. The cube root of 10 raised to the 12th power. Okay, this would be 10 to the 1/3 raised to the 12th. Multiply the exponents. 1/3 of 12 is 4. 10 to the 4th. Well, earlier we did 10 cubed. We saw that was 1,000. If you multiply that by another 10, that's going to give you 10,000. Other types of problems where knowing how to rewrite something, a radical problem in terms of exponents is going to be a lifesaver here. The cube root of 25 is a number that you multiply by itself 3 times and gives you 25. There's a number, but it's not a pretty number, right? It's some kind of a decimal. Same thing with the 6th root of 25. So neither of these radicals are pretty numbers, but if it turns out when you multiply them together, you get a very nice number. And to see what that is, it's easier if we rewrite this with fractional exponents. The cube root of 25 is the same as 25 to the 1/3. The 6th root of 25 is 25 to the 1/6. And then remember, if I'm multiplying, my bases are the same. What do I have to do with the exponents? I need to add them. So I have to figure out what 1/3 plus 1/6 is. So you need a common denominator. Between 3 and 6 would be 6. So I want to multiply this one top and bottom by 2. That gives me 25 to the 2/6 plus 1/6 is the same thing as, remember, adding fractions, just add the numerator, keep the denominator. 25 to the 3/6. Now here's a good argument for reducing your fractions. That's the same as 25 to the 1/2, which we know means the same thing as the square root of 25, which is, of course, 5. Another good opportunity for practice. Number 4, try pausing the video. Model what we did on this one. Of course, this time we're dividing, but the cube root of 16 divided by the 12th root of 16 simplifies to something nice. Okay, so numerator is 16 to the 1/3. over 16 to the 1/12th. When we divide, as long as the base is the same, we're going to subtract the exponents. So that's going to equal 16 to the 1/3 minus 1/12th. To do the subtraction, we need a common denominator, which is 12. So we'll multiply that 1/3 top and bottom by 4. I get 16 to the 4/12ths minus 1/12th, which is 16 to the 3/12ths, which is 16 to the 1/4th, which is the 4th root of 16. And this has come up a few times already in this video here. That's 2. Okay, finally, we're not really solving for something here, but there's situations in calculus where you get a weird answer involving radicals and you have to simplify it to something nicer. So say I had the square root of the cube root of the 4th root of some number x, and I wanted to simplify that to a single radical. Remember, square root means we can put an invisible 2 there. Well, if I rewrite this, starting with the outside, taking the square root of something means I'm raising it to the 1/2. But what am I taking the square root of? I'm taking the square root of the cube root of something, which means I'm taking the square root of something raised to the 1/3. And what is inside the cube root is the 4th root of x, which is the same as x to the 1/4. And when you have a power raised to a power raised to another power, we're going to multiply these exponents. And multiplying just straight across. So 1/4 times 1/3 times 1/2, multiply the numerators. That gives me x to the 1st. Multiply the denominators. 4 times 3 times 2. 12 times 2 is 24. Now it says simplify to a single radical. So then what would that mean? X to the 1/24th is the same as the 24th root of x. Maybe this is a little different. It's not the same. Maybe try pausing the video and see if you can rewrite this as just a single radical. Okay, so let's start with the outside square root. The outside square root is certainly raising some stuff to the 1/2. And what is it that's inside? It is x. Okay, now, to be clear, when you see something like x root x, for example, with numbers, when you see 2 square root of 5, that means 2 times the square root of 5, right? 2 times the square root of 5. So this is really x times the square root of x, and that square root of x, if I rewrote that with an exponent, would be x to the 1/2. Now, there's a couple ways we could go to simplify here. If you have these both multiplied raised to the 1/2, that you can multiply the exponents, but you do have to make sure you do both of them. Alternatively, I could combine these two, which is, I think, the approach I would take. Remember that if you just see x, that's the same as x to the 1st. And if I wanted to add the exponent, I could always think of this as x to the 2/2, right? That's x to the 1st. So when I multiply these, I add the exponents, that's going to give me x to the 2 plus 1, 3/2. And then raise that to the 1/2. Multiply the exponents now, because it's a power to a power, 3/4. It's x to the 3/4, which as a radical, we saw that 4 means it would be the 4th root of x. Now here you could do it either way. When we talked about with real numbers, if you decided it was easier to have the exponent out here, but it wouldn't be incorrect to also put the cubed inside. Either one of these would be fine. All right, hopefully this makes sense. Let me know if you have any questions, and thanks for watching.